Good morning. We are Team 52286 Tornadoes. We are a rookie team and we are all third and fourth grade.
For the robot, we split into 3 pairs and built 3 base robots. Each base robot contains 2 large motors, 2 medium motors, and 2 color sensors. We made a final one that combines all the good features of each robot. The final base robot is compact and has 2 color sensors in front with the light shield. We use dog gear so our attachments can easily go on and off. Later, we also added counterweights to the back of a robot to balance out the weight of the attachments in front.
We created several My blocks that will be useful during the competition season. Yaw angle turning. For this function, the robot uses the gyro sensor to turn to a target angle using the original starting position at home base as a reference point. The robot turns clockwise or counterclockwise depending on whether the current angle is greater or less than the target angle. Stop at line. We used RLI to measure the line's white, black, white pattern. Follow line. We built a proportional line follower to follow the edge of the white, black, white line. The robot is able to follow either edge of the black line using either of its color sensors. KP is the scaling factor that determines how smoothly or how sensitive the robot is to turns. Gyro straight. This function allows us to go straight while we are moving long distances. You can follow the angle provided by the gyro sensor. It also enables us to turn and keep moving at the same time. We also created variations of these My blocks by adding conditionals. For example, follow a line until the other eye sees an intersecting line.
We are doing a total of 16 missions for a maximum possible 445 points. We split the mission into 3 runs based on their geographic location. This table shows all the missions we're doing and the points.
For round 1, the robot runs along the south wall and completes 8 missions. Platooning trucks, home delivery, large delivery, innovation project model, cargo connect bridges, and unused capacity for a total of 160 points. Equipment inspection bonus gives a bonus point of 20, making the score 180.
In our code, our robot moves backward to align itself with the south wall. It moves forward and turns east facing the bridge. The robot moves forward, latching both platooning trucks to the bridge. It backs up and turns, moving backward and aligning itself with the south wall. It moves north a bit, then goes east, stopping at the sorting center. The robot turns facing north, then backs up into the south wall. It does the home delivery mission and moves north. It stops at the cargo connect circle and drops the cargo with the innovation product inside it. Then it does the bridge using a series of back and forth movements. Finally, it pushes the blue container into home.
For run 2, we are doing engine switch. Unload cargo plane, cargo connect, and apply for transportation journey.
The robot initiates at the wall facing north. It goes forward and stops at the line. The robot follows the line until it sees the corner. It goes forward a little bit more to go to the engine switch and flips the engine. It then moves backwards until the right eye sees the line. It then turns to face the cargo plane. It goes forward and the right arm brings down the cargo. Then the arm moves back up and moves backward. It turns on it faces the transportation journey plane and the arm hooks itself in the plane. It moves the plane out and goes back to the home base of the plane.
For run 3, we're doing load cargo, unload cargo ship, airdrop, and accident avoidance for a total of 150 points, with 6 more precision tokens making the score 200.
The robot starts off against the south wall. It goes forward and then turns diagonally to follow the line, counting the number of intersecting lines. It stops in front of the cargo ship and turns north, and then goes forward and loads the cargoes onto the ship's west deck. Then it turns toward the crane next to the cargo ship and uses the attachment to push the crane east. After that, it follows the rest of the line and counts 1 intersecting line so it can push the airdrop, and finally does mostly reversing movement to go to accident avoidance.
Our old attachment didn't control a platooning truck that well, but our new attachment lifts it up slightly so that it is easier to control. We used the attachment so we didn't need to make a robot face the doorstep or maneuver through tight spaces. We dropped the cargo with the innovation project model and pushed it forward so that it is fully in the circle.
For these missions, we use the same attachment in the home delivery mission to save time and use the robot to push the container into home.
We initially did the cargo plane first, followed by the engine switch, but later realized that it's actually easier to do the engine switch as the first mission.
The same attachment is used for the cargo plane and transportation journey. For the cargo plane, our attachment is not able to completely push down the lever. We later changed the shape of the attachment so that it can press down completely.
Our old attachment for the mission was a forklift that will lift the cargo and set it down, but then discovered that the cargo doesn't balance easily or falls or stays on the attachment when the robot leaves. Our new attachment, however, makes balancing easier, as two holders on axles that hold the cargo. When it pushes against the ship's deck, the front holder gets pushed to the back and the cargo rests on the ship's deck instead. This was one of the hardest missions in Run 3. At first, we decided to use a passive attachment on the side and the gyro function, but found out the passive attachment wouldn't apply enough force anyway, so we decided to crash head on with the stick, which would then move forward and push the cargo all the way out east.
For the last two missions, we passively pushed both of them for a total of 50 points. Thanks for listening.